What if Tesla is on the verge of rewriting the rules of automotive manufacturing once again? Across the industry, growing reports suggest that Tesla is preparing a major evolution of its revolutionary Giga Press technology. Sources indicate that significant changes are being made to the production system behind the upcoming Cybercab, a move that could dramatically increase manufacturing speed while reducing costs on a scale never seen before. But why is Tesla upgrading a system that already transformed vehicle production? Has the company discovered a better way to build cars? Or is Elon Musk laying the foundation for a future where vehicles can be produced faster, cheaper, and in far greater numbers than anyone imagined? Industry insiders believe these latest developments could accelerate the Cybercab program far beyond previous expectations. If those reports are accurate, Tesla may be positioning itself years ahead of traditional automakers in the race toward next-generation transportation. Yet the most fascinating part of this story remains hidden behind factory walls. Few people are talking about the engineering breakthroughs that could make this upgrade possible. These changes may not only reshape Tesla's factories, but could influence how cars are manufactured around the world for decades to come. So, what exactly is Tesla changing? Why does the Giga Press 4.0 matter so much? And could this be the beginning of an entirely new era in automotive production? Stay with us until the end, because we're about to uncover the technology, the strategy, and the hidden details behind Tesla's latest manufacturing revolution. And if you enjoy exploring the future of innovation, be sure to subscribe to the channel and turn on notifications so you never miss our latest updates. Just a few years ago, building a car was an incredibly complicated process. Inside a traditional automotive factory, thousands of individual components had to be manufactured, transported, aligned, welded, and assembled before a vehicle could finally take shape. Even the structural frame of a car required numerous metal pieces to be stamped separately and then joined together through an extensive network of welding operations. To complete this process, manufacturers relied on vast production lines filled with robots, specialized machinery, and skilled workers. Something as simple as the underbody of a vehicle could consist of dozens of separate parts connected through hundreds of weld points. For decades, this approach remained the standard across the global automotive industry. Then Tesla came along with a radically different vision. Instead of building a vehicle structure from many smaller pieces, Tesla proposed creating large sections of the car as single components. The company called this manufacturing method Giga casting, and it quickly became one of the most talked about innovations in modern automotive production. At the heart of the system are enormous machines known as Giga Presses. These giant casting machines inject molten aluminum into massive molds, producing entire sections of a vehicle in one operation. Components that once required dozens of separate pieces and countless welding steps can now emerge as a single cast structure. The impact of this change is difficult to overstate. By eliminating numerous individual parts, Tesla significantly reduces assembly time, simplifies production, and removes many of the bottlenecks that traditionally slow vehicle manufacturing. Fewer components also mean fewer suppliers, fewer logistical challenges, and a more streamlined factory operation. The benefits extend beyond speed alone. With fewer parts to manage and assemble, manufacturing costs can be reduced while production efficiency increases. In some areas of Tesla's factories, tasks that once required multiple workstations and large numbers of robots can now be completed in a single manufacturing step. What began as a bold experiment has evolved into a manufacturing strategy that many industry experts believe could reshape how vehicles are built in the future. And now, with Tesla reportedly preparing the next evolution of its Giga Press technology, the company may be pushing this revolutionary idea even further. What's new in Giga Press 4.0? When Tesla first introduced the Giga Press, many experts viewed it as one of the most disruptive manufacturing innovations the automotive industry had seen in decades. The idea of replacing dozens of individual components with a single giant casting seemed almost impossible at the time. Yet Tesla proved that it could work, and the results began changing the way manufacturers thought about vehicle production. Now, the company appears ready to take that concept even further. Reports surrounding the next-generation Giga Press 4.0 suggest that Tesla is developing an even more advanced manufacturing system designed to push efficiency to new heights. While Tesla has not revealed every detail publicly, industry observers believe the new technology could dramatically simplify vehicle construction and further reduce production costs. One of the most significant improvements is believed to involve larger and more sophisticated castings. The latest generation of Giga Press machines may be capable of producing bigger structural sections than ever before, allowing Tesla to combine even more components into a single piece. Every part that can be eliminated means fewer assembly steps, fewer connections, and a simpler manufacturing process overall. This strategy reflects Tesla's long-term vision of reducing complexity wherever possible. Instead of assembling a vehicle from hundreds of separate pieces, the company continues searching for ways to integrate more of the structure into larger cast components. The fewer pieces required, the faster a vehicle can move through the factory. Another key area of focus is production speed. In modern manufacturing, every second matters. Even small improvements in cycle times can translate into thousands of additional vehicles produced each year. That is why Tesla engineers are constantly refining the casting process, working to reduce delays and maximize output from every machine. Precision is also becoming increasingly important. Producing massive structural components requires extraordinary accuracy. Even minor inconsistencies can create challenges later in the assembly process. By improving casting precision, Tesla can ensure that components fit together more consistently, reducing manufacturing defects and minimizing costly rework. At the same time, automation is expected to play a much larger role in the Giga Press 4.0 ecosystem. Advanced sensors, intelligent software, and real-time monitoring systems can continuously track every stage of production. Some industry reports suggest that artificial intelligence may be used to analyze critical variables such as temperature, pressure, material flow, and cooling performance, helping identify potential issues before they affect production. The result could be a manufacturing system that is not only faster but also more reliable. Better monitoring allows problems to be detected early, reducing downtime and helping factories maintain consistent output around the clock. Ultimately, the objective behind Giga Press 4.0 is straightforward. Build more vehicles in less time with fewer resources and lower costs. If Tesla succeeds, this latest evolution of Giga casting technology could represent another major step toward the fully optimized factories Elon Musk has envisioned for years. And if these improvements perform as expected, Giga Press 4.0 may become the foundation of Tesla's next generation of vehicles, and potentially a model that automakers around the world will be forced to follow. Why is the Cybercab so important for Tesla? If we talk about Tesla's future plans, Cybercab may be considered one of the company's most ambitious projects because it is not just a new electric vehicle, but part of the bigger vision that Elon Musk has been presenting to the world for many years. That vision is fully autonomous transportation, where people no longer need to drive themselves. The biggest thing that makes Cybercab special is that it is being designed as a robotaxi from the very beginning. In other words, it is a vehicle that can drive itself and take passengers from one place to another. That is why many features normally seen in traditional cars do not appear in its concept. Tesla has developed it with a future in mind where the role of the driver is almost eliminated. One of the most talked about features is the absence of a steering wheel. Normally, a car is identified by its steering wheel and pedals. But the idea behind Cybercab is different. Tesla believes that if a vehicle can drive completely on its own, the need for these controls becomes much smaller. This thinking is what makes Cybercab different from other EVs. Tesla's goal is not just to showcase new technology. The company wants to produce it on a large scale. If a robotaxi service is to become successful, it will require not thousands, but millions of vehicles. That is why Cybercab is being designed from the start with mass production in mind. Another major objective of this project is to provide lower-cost transportation. Today, taxi and ride-sharing services can be quite expensive in many cities. Tesla believes that if the need for drivers is reduced and vehicles can be produced at lower cost, then the cost per trip could also fall significantly. This could make transportation more accessible for ordinary people. Elon Musk has long spoken about a future where Tesla vehicles are not just personal cars, but part of a large autonomous transportation network. Cybercab is considered one of the most important pieces of that vision. That is why Tesla is moving forward with this project so seriously. What major changes are taking place in the Cybercab's casting process? The most interesting thing about Cybercab is not just its design or its robotaxi concept, but also the way it is being built. Tesla is making changes to the vehicle's casting process with the goal of making the entire manufacturing process much easier and faster than before. That is why Cybercab is considered one of Tesla's most advanced manufacturing projects so far. In traditional vehicles, the front and rear sections are built by joining many different metal parts together. Each part is produced separately and then connected through welding and assembly. But with Cybercab, Tesla is moving toward large-scale use of front casting and rear casting. This means that large portions of the vehicle's front and rear structure can be produced using a smaller number of casted pieces. At the same time, the company is also focusing on underbody integration. In simple terms, several sections of the vehicle's lower structure are being combined into a less complex design. This can reduce the need for separate parts and make the overall structure easier to build. The direct benefit of fewer parts is a lower component count. Where many small parts were once needed to create a section, the same work can now be completed with fewer pieces. This not only simplifies manufacturing, but also makes the supply chain easier to manage. Tesla is also trying to simplify the assembly line. When there are fewer parts to connect, fewer steps are needed on the production line. This can increase manufacturing speed and make it possible to produce more vehicles at the same time. Another advantage of this new process is seen in structural improvement. With fewer joints and fewer welding points, the vehicle structure can be made stronger and more stable. At the same time, some manufacturing complexities can also be reduced. If we look at traditional vehicle manufacturing, a modern car contains thousands of different parts. These include body panels, frame sections, brackets, support structures, and many small and large components. All of these parts are supplied separately and then assembled in the factory to create a complete vehicle. That is why car manufacturing is considered a long and complex process. Tesla has been trying to reduce this complexity for years. The company believes that if a vehicle can be built using fewer parts, production can become faster, cheaper, and more efficient. This same thinking can be seen behind Giga casting and other new manufacturing technologies. With Cybercab, Tesla wants to take this idea even further. The main goal of the company's manufacturing simplification strategy is to reduce the number of parts used in the vehicle as much as possible. When one large casted section replaces many smaller parts, the need for dozens of components can be eliminated. Tesla's well-known unboxed production strategy is also part of this approach. In this model, the vehicle is built in separate large modules rather than on a traditional assembly line, and those modules are later joined together. This can make the production process more flexible and faster. Another major advantage of having fewer parts is the reduction in welding points. Where hundreds of welds were once required, the number can be greatly reduced because there are fewer connections. This saves time and makes manufacturing simpler. In addition, fewer suppliers may be needed. When fewer parts are produced, the number of companies supplying those parts can also decrease. This can simplify logistics and reduce transportation costs. The biggest benefit is seen during assembly. Connecting fewer parts is always easier. This helps increase factory speed, lower production costs, and allows more vehicles to be built in less time. Can the Cybercab become the world's cheapest Tesla? One of the most intriguing aspects of Tesla's upcoming Cybercab is not its futuristic design or autonomous technology. It's the possibility that it could become one of the lowest-cost vehicles Tesla has ever produced. Although Tesla has not officially revealed the final price, many industry analysts believe the company's manufacturing strategy is clearly aimed at making Cybercab significantly more affordable than traditional electric vehicles. If Tesla can successfully execute its plan, the Cybercab could represent a major shift in how low-cost transportation is delivered to the public. The foundation of this strategy begins inside the factory. Over the past several years, Tesla has focused relentlessly on simplifying vehicle production. Through innovations such as giga casting, advanced automation, and streamlined assembly methods, the company has steadily reduced the complexity of building a car. Every component removed from the production process saves time, labor, and material costs. The logic is simple. When fewer parts need to be manufactured, transported, and assembled, overall production becomes more efficient. A vehicle that takes less time and fewer resources to build can ultimately be produced at a lower cost. However, manufacturing efficiency is only part of the equation. For every electric vehicle, the battery remains the single most expensive component. In many cases, it accounts for a substantial percentage of the vehicle's total cost. This is why Tesla continues investing heavily in battery technology, production methods, and supply chain improvements. Every reduction in battery cost has a direct impact on the affordability of the final product. Cybercab is also expected to benefit from a highly optimized assembly process. Reports suggest the vehicle is being designed from the ground up, with manufacturing simplicity in mind. By reducing unnecessary complexity and minimizing assembly steps, Tesla can potentially increase factory throughput while lowering production expenses. But perhaps the most powerful cost advantage comes from scale. Tesla's long-term vision for Cybercab extends far beyond a niche vehicle program. The company is reportedly planning for extremely high production volumes. In manufacturing, economies of scale can dramatically reduce costs as production numbers increase. The more units produced, the lower the average cost of each vehicle becomes. If Cybercab reaches production levels measured in the millions, Tesla could unlock cost efficiencies that few competitors would be able to match. This would allow the company to push pricing lower while maintaining profitability, a combination that has the potential to reshape the market. That is why many experts view Cybercab as something much larger than a new Tesla model. They see it as a key part of a broader vision centered on affordable autonomous mobility. Rather than focusing solely on vehicle ownership, Tesla appears to be working toward a future where low-cost, self-driving transportation becomes widely available to the public. Should that vision become reality, the impact could extend far beyond the automotive industry itself. Traditional taxi services, ride-sharing platforms, and urban transportation networks could all face significant disruption as autonomous vehicles become more accessible and economically viable. For Tesla, Cybercab is not just about building another car. It is about creating a transportation system that could fundamentally change how millions of people move from one place to another in the years ahead. What are the biggest challenges facing Giga Press 4.0? Giga Press 4.0 may look like an impressive technology, but it also comes with major challenges. From the outside, it may seem like a giant machine can easily produce large vehicle sections, but in reality, making this process successful is quite difficult. The first challenge is casting defects. When molten metal is poured into a very large mold, temperature, pressure, and metal flow must be controlled with extreme precision. If even a small issue occurs, the finished part may develop cracks, air pockets, or other defects. Preventing these problems completely in large casted components is not easy. Another challenge is repair complexity. In traditional vehicles, if a small section is damaged, replacing it is relatively simple. But when a large structure is made as a single piece, repairs or replacements can become more complicated and expensive. Production downtime is also a major concern. Machines like the Giga Press are among the most important pieces of equipment inside a factory. If the machine stops for any reason, a large part of the production line can be affected. This can directly impact vehicle manufacturing speed. The importance of quality control also increases significantly. When a large section of a vehicle is produced in a single casting, every piece must be inspected very carefully. Even a small defect can lead to bigger problems later. In addition, maintaining such massive machines is not easy. Regular inspections, part replacements, and keeping the machine in proper condition are extremely important. If maintenance is not done properly, production can be affected. Material consistency is another important issue. The quality of the metal must remain the same in every casting. If there is even a small variation in the material, the strength and performance of the finished parts can be affected. Tesla also faces scaling challenges. Making the technology successful in one factory is one thing, but maintaining the same level of quality across multiple factories around the world is much more difficult. At the same time, factory integration is also essential because the new machines must be connected properly with the entire production process. What is the current status of Cybercab production? Interest in Cybercab continues to grow, but the biggest question is how far its production has actually progressed. Tesla has been preparing for this project for quite some time. The company does not just want to launch a new vehicle, but is trying to build an entirely new transportation system. First, when it comes to factory preparation, Tesla is getting its manufacturing lines ready for Cybercab. Several changes are being made with new production technologies, gigacasting, and automation systems in mind. At the same time, the company has also developed multiple Cybercab prototypes that are being used for design and technical testing. Before full-scale production begins, pilot production is also extremely important. In this stage, a limited number of vehicles are built to evaluate the entire manufacturing process. This helps identify any technical issues that need to be solved before mass production starts. The necessary manufacturing equipment is also being installed in factories. New machines, robots, and casting systems are considered essential for large-scale Cybercab production. Then comes the testing phase. The vehicle's safety, software, battery, and autonomous driving systems are continuously evaluated. Since the entire Cybercab concept is based on autonomous transportation, testing becomes even more important. However, having the technology ready is not enough. Tesla may also face regulatory hurdles. Different countries and states have different rules for autonomous vehicles, so obtaining approvals will be a critical step. Tesla's goal is to achieve large-scale production in the future so that Cybercab can reach millions of people. But the biggest question still remains: Is Giga Press 4.0 simply Tesla's new machine? Or could it become the technology that defines the direction of future car factories? Giga casting has already shown that fewer parts, faster production, and simpler assembly are possible. If Giga Press 4.0 makes this process even better, the way vehicles are manufactured could change completely in the coming years. Future factories could become more automated than ever before. Where vehicles are built through hundreds of steps today, the same work could be done faster tomorrow, with fewer steps and more advanced machines. AI-driven manufacturing could also become a major part of this transformation. Smart systems may monitor production, identify problems early, and make the entire factory more efficient. If production costs fall, vehicle prices could also be affected. More affordable EVs may enter the market, making electric vehicles more accessible to customers than ever before. On the other hand, global EV competition could become even stronger. Seeing Tesla's success, other manufacturers may also move toward gigacasting and advanced automation. But Tesla's advantage is that it has been working on this technology for years and already has real-world production experience. The coming years will determine whether Giga Press 4.0 becomes only Tesla's strength or a new industry standard. But one thing is clear: the world of vehicle manufacturing is changing rapidly. If Tesla truly starts producing Cybercab at massive scale and at extremely low cost, could traditional car factories become outdated technology in the years ahead? What do you think? Could Tesla's Cybercab and Giga Press 4.0 really change the future of the auto industry? Be sure to share your opinion in the comments. And if you enjoyed this video, don't forget to subscribe to the channel.